Hello everyone. This is the last of the parts in the descriptive statistics. Here we are going to be looking at location of the data measures. A little recap. So when we started with this chapter on descriptive statistics, we talked about how we can summarize the data in a graphical form, where we looked at pie charts, bar graphs, histograms, stem and leaf plots, and dot plots. Then we went on to the numerical summaries of the data. In the numerical summaries, we studied the measures of the center of data, mean, median, mode. We looked at the measures of the spread of the data set, where we focused on standard deviations, variance range, interquartile range. In this video, we are going to be studying the measures of location of data. The focus will be on quartiles, percentiles, and median. And then finally, we will look at the 5-number summaries, box plots, and how outliers can also be graphically represented as well as calculated. So let's begin with measures of the location of the data. Now, the two most popular measures we have already learned are the center of the data set, which is mean and median, and then the variability in the data set was represented by the spread of the distribution. Over here, we are looking at how the location of the data describes the data set. Now, this is a point where a certain percentage of observations in the data set fall above or below that point. So let's start with percentiles first. Now, what's a percentile? A percentile simply means any number k between 0 and 100 such that the kth percentile of a data set is a value where k% of the observations in the data set fall above or below that value. Let's take an example which will make things clear. Now, suppose an exam was given in a mathematical finance class and they found that 90% of the final scores were at or below 260, which simply means that 260 is the 90th percentile. That to the left of the 260, 90% of the students in that mathematical finance class scored value of 260 or below. So also we can say that 10% of the scores in that mathematical finance class is above 260. So we do not need to know how many students were there in the class or what, but we know that 260 is that score value where 90% of the scores were below that or at that point, or 10% of the scores were above 260 score value of the mathematical finance scores. Okay, so that's in relationships of percentiles. Then we have quartiles. Now, quartiles is very similar to our quarters, guys. So we know 25 cents is 1 quarter, 50 cents is 2 quarters, and 75 cents is 3 quarters. So keeping that in mind, we say the quartile. So here is the scenario. So suppose these are the observations. We do not know what value, so this is Q1. Q1 simply means that 25% of the observations are to the left of Q1. Okay, what's Q2? Q2 says that 50% of the observations, so I'm just using different, ways of representing the 50% of the observations are less than or equal to Q2. Now, what's Q3? Q3 is 75th percentile, Q3, and it says that, they can have some stars. So 75% of the observations are less than or equal to Q3. And 25% of the observations are above Q3. So let's have some check marks. So 25% of the observations here are above Q3. So in this nice little picture I have for you, so here is the first quartile, which I had made in the previous slide. Then 50%, 25, 25, 50% is the number of observations which are less than Q2. And then 75, 25, 25, 25 are the observations or data values which is less than the third quartile, Q3, or the 75th percentile. Different names you can give. And 25% of the observations are above the third quartile or Q3 or 75th percentile. Now we talked about interquartile range, if you remember. That's like in terms of when we're doing the spread of the data set. So interquartile range actually is the 75th percentile. So I will make some nice little big circles. So 75th percentile. So these little big circles you see, which is between Q1 and Q3, that is your IQR, the interquartile range. Remember, it also shows the variability in the data set, but at the same time it says all the observations which lie between the Q1 25th percentile or Q3, which is the 75th percentile. So we have got our concepts base ready here. Let's start with examples now. Okay, so here's an example. It's a data set of 20 people who gave their, that this was the number of hours they watched TV weekly. So randomly, we have 20 people's number of hours of watching TV. When you look at this one, they are all over the place. So the question is, we would like to find the quartiles first by hand and then with the calculator. The first thing is we are doing it by hand. We look at all the observations and we write them down from the smallest value to the highest value. And I've done that here for you. The smallest is 3 and the highest is 51. Now, when you want to find the quartiles, remember we're looking at the first is the median, which is Q2. Remember, Q2 is the median. Depending upon how many observations they are, odd or even, we figure out the median value. Now, there are 20 of them, so that means the mid two values, that is the 10 and so you have 10 observations and 10 observations. So here is the mid value, because there are 10 observations on the left hand side, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 10 are also on the right of this little vertical red line. Okay, now to find, because these are even observations, you basically add 26 and 29, divide by 2. That gives us the median, which is 27.5. Okay. Now we have to find the quartiles. Now to find the quartiles, once again, we look at how many values are on the left-hand side of this median, and we're going to take the half of it. As there are 10 values, so what we're going to do, we're going to look at the value 5th and 6th, so which is basically 20 and 21. So these two values. So there are 4 values on the left and 4 values, 22, 23, 25, 26 on the right of it. So we're going to once again take the mid of this, of 20 and 22, which basically gives us 21. So 20 plus 22 divided by 2 equals 21. Now that takes care of Q1. What about Q3? Q3 is that we go on the right-hand side of the median. And once again, there are 10 values. So we will look at the 5th and the 6th value, and they're already in ascending order. So we say 1, 2, 3, 4, 5, 6. So basically 31 and 32. Because on the left of 31, 32, there are 1, 2, 3, 4, and on the right, 1, 2, 3, 4. So exactly the same number of values. So basically Q3 is now the middle of this, which is 31 plus 32, which is the average of the two numbers next to it, is 31.5. Okay, so we have got Q1, Q2, Q3. And if I want to find interquartile range in the 5 numbers summary, so let's look at that. Interquartile range, guys, we already know is Q3 minus Q1. Okay, so the interquartile rate is Q3 minus Q1. And what from our previous example, what's Q3 minus Q1? It's 31.5 minus 21, which is 10.5. Now, some properties of IQR. IQR is not sensitive to extreme values. It's therefore a resistant measure of spread. And we use this as the measure of spread when we are looking at median as the measure of the center. Now, what's a 5-number summary? 5-number summary is basically the minimum, the maximum of the value of the data set, and then the quartiles, Q1, Q2, Q3. Okay, so let's go back to our problem again and write down the values which we already have done in the slides before this. So once again, we are looking at the number of hours of TV which is watched by some random number of people. They're the same values. So minimum we already know was 3. If you go back to this little slide, guys, already which shows it by, it is in the ascending order. The minimum is 3 and the maximum is 51. It's already done for us. And then these 3 values, we will just pick it up and put it over here. Minimum is 3. Maximum is 51. Q1 was 21. Q2 was 31.5. And Q3 is 27.5. Okay. Let's go back and also check once again. There it is. Sorry. Q2 is 27.5 and Q3 I just, flip-flop. Okay, just let's made a mistake here. Okay, so Q2 is 27.5 because Q2 is less than definitely Q3. This is 31.5. Okay, good. We caught this mistake. Okay. Now, let's look at some other ways of defining outliers. Now, outliers, remember when we talked earlier, it was like extreme data values. Now, many statisticians say, oh, this is one way of finding outliers, this is another. So there are various ways. So one of the ways of finding an outlier is using these quartiles and interquartile range. So outliers, as we said earlier, they are the values that are very, very far from the rest of the data set. So what we do is we find a lower limit and an upper limit. So it's LL and UL. Lower limit is like you take the quartile, Q1, first quartile, and subtract 1.5 times the interquartile range from it. The upper limit is you take the third quartile, Q3, and add 1.5 times the interquartile range. So some statisticians say the data which is greater than the upper limit or less than the lower limit are potential outliers. Guys, very important, potential. Now, data which are more than, some of them say, oh, data which is more than 2 or 3 standard deviations from the mean are potential outliers. Okay. So there is no one best rule of saying, oh, this is an outlier and this is not an outlier. So very different ways of finding an outlier. It depends upon what you prefer. So let's look at some of these examples. Now, if human heights of 8 feet 11 inches, oh, definitely that's an outlier. Miles per gallon rates greater than 95. Oh my gosh, that's an amazing car you have then, or a vehicle. Or number of people who are struck more than 5 times by lightning. I don't think so. We should be liking that. And then let's look at 20 people who reportedly watched falling number of hours of TV weekly. We would like to say if there are any outliers. Okay, so IQR, we have found it to be 10.5, then lower limit, just plugging in the values. We get 5.25 and 47.25 for the upper limit. I've done the work here for you guys. You can just look into it, okay? So Q3 is 31.5, 1.5 times 10.5. So it's 31.5 plus 51.75, and these are the values. So according to one of the ways of looking at a potential outlier is less than lower limit. And yes, definitely we have one value, 3, or more than the upper limit, which is a 51 over here. So we definitely have two potential outliers in our set. Okay, now, so this is all computational work. It is said that picture's worth 1,000 words. So, is there any way to represent all those things we have been talking about? Sure it is. And that is called a box plot. Okay, so box plot, or box and whisker plots, or box whisker plots, whatever you want to call it, it gives a good graphical image of the concentration of the data. It shows how far the extreme values are from the most data set. It's made with the help of 5-number summary and potential outliers, and also gives us the idea of a center spread or skewness in the data set. And we also use sometimes these values to compare data values of different data sets. Okay, and also use how close other data values are to them. So many ways we can also look at them. So let's look at a graphical image of a box plot. Now, I have made a horizontal way, but sometimes you can make it as a vertical way also. So let's start with the horizontal displacement of the box plot. You have a little box. On the left-hand side, you have Q1, and somewhere in the middle is Q2, which is median, and Q3. And then what we do is we look at the potential outliers if they are present, and we do asterisks to represent them. And the box plot has some whiskers. Now, in order to find these two whiskers, what we do is we look at all the observations which are on the left-hand side of the Q1, and which is the smallest and not an outlier. That's a value which goes as this whisker point, last point for the whiskers, or the adjacent values here. And similarly, we would find this little vertical line, which would be the largest observation, which is not an outlier. So that's how we do it. Or sometimes we will see if you're using some softwares, they have box plots like this. So in this one, you say this is Q1, this is Q2, this is Q3. You have the largest observation, you have the smallest, and then if you have some outliers, you can, represent like that. So it doesn't matter how you do it, do it in this form or the other. Now the steps to find a box plot. So here are the steps for a box plot. First of all, we find 5-number summary. We find the lower and the upper limits. We mark and label the quartiles with vertical lines and box them in. Find the potential outliers and, show them with the help of an asterisk, label them. And then we find the smallest and the largest values occurring within the upper and the lower limits with vertical lines, and connect the lines to the box, which are called the adjacent values or whiskers, whatever you want to say that. So let's go back to our very famous example we have been doing so far, is the weekly reporting of TV by these 20 randomly picked students. Observations or whatever you want to call it. I just so used to saying the word students now. Okay, so what we do is we know 3 is an outlier and 51 is an outlier. And we have already done all the work. We know the minimum value. We know Q1 to be 21, Q2 to be 27.5, Q3 to be 31.5. So let's make a box first. Okay, so we have a box here. Q1 and Q is easily Q1 and 31.5. So this is Q1, Q3. Now to find Q2, this 27, which is more closer to 31.5, so it's not going to be in the middle. Guys, remember, it's not going to be right in the middle of this box, but it's going to be somewhere closer to 31.5. So that's my Q2, 27.5. Okay, so 51 is somewhere here, it's an outlier, and 3 is somewhere here, which is an outlier. We need to find those two little vertical lines. So now let's look at the next number after 3, which is not an outlier. And the next smallest number is 13. If you notice, this is 13 is the only one. Closer to 21 than 3, so just eyeball and make a vertical line, then draw a whisker or a straight line towards touching the box. So this is the smallest observation, which is 13. Now let's look at what are the values which are closer then, which is not an outlier, but it's still a data value. So we have 51. Oh, there's 39. Is any other number greater than 39 here? No, so 39, which is more closer to 31.5. So we can roughly say, hey, 39. So here's a box plot, guys. Okay. Okay, now let's look at this problem, which says during a recent seminar at the University of Florida, students having accounts on a mainframe computer had a storage space, which is described by this 5-number summary. Minimum is 4, the first quartile is 256, the median is 530, 75th quartile is 1105, maximum is 320,000. Oh, that's straightforward an outlier. We can already see that. So do you think it's going to be symmetric or skewed to the right or skewed to the left? So when you look at all these numbers, even if I make my nice little box plot, we can do a box plot which will help us out. So we have Q1. So Q1 is 256. Median is 530 and Q3. So it's roughly in the middle of these two, you can say. So that's 530, 1105, is somewhere here. 211, what you get is 9 and some rough somewhat like this. Minimum is 4. Okay, so minimum somewhere is 4. Still closer to this. So even if we take the IQR to find if it is a lower limit or not, we can quickly do the math. 1105 minus 256, 849, and then you multiply by, so let's find the IQR. Definitely is 320,000. Remember, guys, it's way far from all these values. It's definitely a potential outlier. We don't even have to worry about that. It's so logical. But 4 is something I like to still do a little math in terms of the lower limits here. So IQR we found to be 1105 minus 256, which is 849. And we multiply by 1.5 times IQR, which is equal to 1273.5. Now Q1 minus this, so Q1 is 256, so lower limit is 256 minus 1273.5. Definitely 4 is way ahead. So this is basically like the whisker on this. Now here we don't know what is going to be the whisker, so I just simply go ahead and make this one here. So clearly, so what is it? The answer is minus 1017.5. Okay, so 4 is not a potential outlier, but 320,000 definitely is. But if you want to still do the math here, you can find the upper limit. Just for some of you who like to see numbers, so it's going to be 1105 plus 1273.5. Clearly, this number is in 2000s and definitely much more, 320,000 is way beyond that. So this number is 2378.5. Okay. So let's look at some other, how we can compare. So here's a box plot. So remember we did an example of the data on heights of men and women. So I have some more data sets. So these are for the men and women heights. They are, how many of them are there? 1, 2, 3, 4, 5, 6, 7. So 20. So these are 20, men and women in all whose heights we're looking at. And Then when we find the minimum, so these are the values, the minimum Q1, Q2, Q3, max is 76, 72 is the 75th percentile, median is 69.5. You can plug it in your calculator, so we can do that one of them. And then woman is 63. So let's look at woman's height. Okay, let's do the math here. So what you're going to do is we're going to plug these numbers in L1. So you notice, so what you do here is click on Start, Edit, and then press Enter. So you see some numbers. I don't want these numbers, so I'll take the cursor to L1, press Clear, Enter. So everything's gone. Now we need to fill it up with numbers here. So what I'm going to do is I am going to look at the woman's height here, 63. Then 64, 59, 63, okay, 63, then 62, 68, 65, 62, 68, 65, what else are the numbers? 63, 60, and 61. Okay, 63, 60, and 61. So once again, click on Starts, because we just want the 5-number summary. Take it to Calc. Already one variable stat is highlighted. Press Enter. L1 is already there. Don't do anything else. Take the cursor to Calculate. Press Enter. And here we have it. So remember, the minimum is 59. Okay, that's fine. So these are the 59 is minimum. Q1 is 61. That's fine. And then we take the cursor down. Median is 63. This median is 63. Q3 is 64. That is Q3. And the maximum is 68. Okay. So we have all these values here for the woman's height, and similarly you can check on the men's height, and if there's some mistakes, just let me know, guys. Okay, now one of the ways the questions can be asked is, you can be actually made to compare. Sometimes you're just given a box plot and say, hey, looking at the box plot, what do you think is the median of the men's height? Oh, definitely somewhere around 70. Do you see that? Not close, but some very, very close. So this is 70. So we say, hey, 69.5 or 69, whichever you want. Or the question can be, out of the men's and the women's height, which one do you think is the? Suppose you're not given numbers. So questions can be, oh, what is the out of the men's and the women's height? Which one do you think is the highest in terms of median? Definitely, everything actually for the men's height is highest in terms of the medians. Then you can also be asked, like, what kind of, so looking at the graph, do you think it is right shaped or right skewed or not? So what you normally do is, if you want to look at the distribution, you just create a little curve like this. So here, and mount is always on the median, and then you just roughly draw a curve here. Okay, not a little good one. Okay, so let's try this one more time. You make a little curve here, a little mount on the top of the Q2, and then just take your curve to the right hand side, and the curve, say, to the, not a, here, okay, not a good one. So, but it works for us. Okay. Oops, there we go. You can see something is not, okay. Now that is the best one. Okay, good. So kind of it is roughly, I would say, it's a roughly symmetric one. Let's look at woman's height. How does it sound? Now this, remember, is median. So we draw a mount here. So when we draw a mount here, and then we draw line here, and then we draw a line here. Also, this is roughly symmetric. If you notice over here, kind of roughly symmetric if you don't know the numbers. You can say that. Okay. Then some questions can be asked, is like looking at the this box plot, can you give us the rough idea about what is the range of women's heights? So what we normally do is just eyeball, okay, somewhere close to 60, say 58 or 59 is the minimum value here, say 59. And the highest value, we can just say, okay, there is no potential outlier, so you don't have to worry about it. So look at the value here is closer to 67.5, so 67. So you can say, yeah, roughly the range is 67 minus 59, which comes out to be 8. So that's how some of the questions can be asked by looking at what you guys give. Okay? Thank you.